We know how to find the slope of a straight line. If you have this straight line at x1, y1 and x2, y2, we'll write the points. We use the slope formula. We also know that y is same as fx. So instead of writing y, I can replace it with fx. For example, y1 can be written as fx1. So the point x1, y1 can be written as x1, fx1. And the second point can be written as x2, fx2. Now, to find the slope, we use the slope formula, which is m equals delta y over delta x, which is y2 minus y1 over x2 minus x1. For a straight line, this is the method we use. But if you are given a curve, you cannot use this formula because the slope at every point is different. Using derivative, we will see how to find slope at every given point of this curve. Let's say we are trying to find the slope at this point. Now, to do that, you will take a small segment at that point. Let's say here. So this is the small segment I'm talking about. It looks like this. If you zoomed in, it can be considered as a straight line, this small tiny segment. And then, if it's a straight line, we can use the slope formula. Let's see how it's done. I will represent this on a graph. So we have x-axis, y-axis, and this point is x, this is y, which is same as fx. So this point is x, fx. Now the second point, remember the points are really close to each other. That means this is x, so this is not far from x, it's almost x. And that means this distance is a very small number. In calculus, we use h to represent small values. I will assume it's h. So if this point is x, the second point would be x plus h. And now the x coordinate of this point is x plus h, and then the y value using this logic would be f of x plus h. So f of x plus h. When you use the slope formula, it is y2 minus y1 and x2 minus x1. So this is your x1, this is y1, this is x2, and this is y2. It becomes y2 minus y1 f x plus h minus f x over x plus h minus x. In calculus, whenever we have h, which is a very small number, we represent it using the word limit, h going to 0. This means h is so small it's almost 0. We will review the concepts of limit in another video. And this is the slope. Notice that x minus x, they can be cancelled out. So you are left with f x plus h minus fx over h, and limit h is approaching 0. And this was calculated using delta y over delta x. In calculus we use dy, which means change in y, over dx. This is the definition of derivative. what it gives you is the slope of a line that's passing through our point, which was here. And we know that the line that touches the curve at only one point is called the tangent. So this is a tangent line passing through our point of interest. This equation gives the slope of this tangent line passing through our given point.